Hello and welcome to today's lesson. So in today's lesson we are going to talk about the finite difference methods used in the solving of ordinary differential equations with boundary value problems, boundary value conditions in numerical analysis. And we are going to take a question to explain this concept. So the question reads, given the boundary value problem y prime prime equals 4 times y minus x with x lying between 0 to 1 and y of 0 equals 0 and y of 1 equals 2, we have to use a finite difference method to approximate the solution with h equals 1 over 4. And after that, we have to find the solution at x equals 0.5. I hope you get it. So let's note we have this interval here. We have these boundary conditions here, and this is our differential equation. So, solution. Recall that our interval was between 0 to 1. We had x lying between 0 to 1. So that's 0 to 1. And we had our h to be 1 over 4. Our h being 1 over 4 means that our interval has been divided into 4 equal parts. So dividing the interval 0, 1 into 4 equal parts is going to give us 0, 0.25, 0.5, and 0.75 up to the 1. So from here to here we add our h. So 0.25 plus 1 over 4 gives us 0.5, and we do that. So you see we have 5 nodes here. So this is our node, this is another node. We have another node here, another one here, and then so we decide to name these nodes. So we name here 0, 1, 2, 3, and 4. So after that, we know that this was the equation which was given to us in the question. So what we do is that we try to approximate the second derivative here with the essential difference formula. That's yi plus 1 minus 2yi plus yi minus 1 over h squared. Know that h has been given to us in the question. So with this approximation, now let us try to put it inside our main equation. This is going to give us yi plus 1 minus 2yi plus yi minus 1 over h squared. So wherever you find here, you put this here. And this will be equal to 4 times yi minus xi. I hope you get it. So when we get here, then we can decide to, do some algebra here. So we multiply through by h squared, and that gives us this result. Then we try to bring yi here, and this gives us this. When we try to bring this to the left hand side, and after that, we try to, factorize 2yi from here. So doing that, we get something like this. And we know h was given in the question to be 1 over 4. So putting in the 1 over 4 inside wherever we find h gives us this, which can finally be simplified into this. So that means this happens to be the finite difference equation for this particular question. We had 5 different nodes. So with I equals 0, 1, 2, 3, 4, and 5. So we are supposed to find equations for our finite difference equation at all these nodes. So at the node I equals 0, it is going to give us y not equals 0. That's the starting initial boundary condition which was given to us. So there is it. So at I equals 0, y not equals 0. Recall that the boundary conditions were y of 0 equals 0 and y of 1 equals 2. So at the node I equals 0 is going to be this. Then at the node I equals 1, we put 1 wherever we find I here. That is going to reduce our equation to y2 minus 2.25 y1 plus y0 equals negative 1 over 4, 0.25. 0.25 because x1 is equal to 0.25. Let's see why. So you see, x at I equals 1 is 0.25. So we put that inside our equation, and when we do our algebra, we end up with this particular equation here. and this becomes equation 2. Recall we have equation 1 here. This becomes equation 2. Then we go to the node at I equals 2. We make substitution. We get y3 minus 2.25 y2 plus y1, which will be equal to negative 1 over 4 x2. x2 is 0.5, so we can check it out from this place. x2 is 0.5. And know that all our i's, we are putting it inside this equation because this is our difference equation for the question. So that's going to give us this equation here, which is going to be equation 3. Then at node I equals 3, we make our substitution again and we get this here, which happens to be equation 4. Then at the node I equals 4, we are going to get this one, this, because we had two boundary value conditions. So this is for y0 and this is for y4. So at the node I equals 4, we are going to get y4, which is equal to y of 1 will be equal to 2. So that means that after doing this, we have 5 equations, and these are 5 equations. So we are supposed to solve for this for y0, y1, y2, y3, and y4. So putting this inside the matrix form gives us this, as we can see here. And we can see that with the coefficient matrix that we have here, let's name it A, we can see that it is tridiagonal. It is tridiagonal, right? So that means that finding for our y0, y1, y2, y3, y4, we can use the Thomas algorithm. But if this would be very difficult for you to do, then you know you have values for y0 and y4 already. So you can use that to reduce this 5 systems of equation into 3, right? So actually, when you solve this using any method that you know, you're going to get y1 to be 0, y0 to be 0, y1 to be, so have the values here, y1 to be this, y2 to be this, y3 to be this, and y4. So y4 to be 2, because we know y4 is equal to 2. So since you already know the values for this, we can use that to reduce these 5 equations into 3 equations. So when we do that, we are going to end up with this particular system of equation here. I hope you understand. So wherever we find y0 in equation 2, we will put 0 there because it is 0. Wherever we find y0 here, we put 0 there. Wherever we find y4 here, we put 2 there. That is going to give us these 3 equations that we have here. So solving these 3 equations using any method that you know for solving systems of linear equation is going to give you y1 to be 0.3951, y2 to be 0.8265, and y3 to be 1.3396. Recall that we already know the values for y0 and y4 from the boundary conditions which was given to us. So let me show you something here. So remember the question said we were supposed um so we had x between this interval 0 to 1, and it was divided into 4. This was 0.25, this was 0.5, this was 0.75, and this was I equals 0, 1, 2, 3, 4. The question said we should find the value for x at x equals 0.5, and that happens to be 2 here. So that happens to be y2. So that means that at x equals 0.5, our y value is going to be 0.8265. That happens to be the solution to the question. So thank you very much, and I wish you all the best.